Okay, let's discuss on introduction to structural analysis today. First of all, let's get the definition. Structural analysis is a determination of internal forces and deformation in structure due to expected externally applied or induced load and under known support condition. So structural analysis here is a determination of internal forces and deformation. You analyze the structure to know the forces acting internally in the structure and the rate of deformation these forces are going to cause to the structure. Now we have the main load that are applied on structure. The main loads applied on structure, they include one, dead load, which means self-weight of a structure. Two, impulse load, which means load due to occupancy. And three, we have wind load. As the name implies, load due to effect of wind. So dead load has to do with the self-weight of the building, excluding all load in the building which are due to occupancy, such as the people living in the house, including the furnitures. Any load that are not part and parcel of the structure, so that they can be mobilized, are classified as impulse load. But the core structure itself, the core weight of the structure itself, is a self weight of the structure. Now we have the wind load, as the name implies, load due to wind effects. As a basis of structural analysis, you need to know that we have two classes of plane structure. That is, there are two classes of plane structure that exist in structural analysis, and they include one, the determinant plane structure, and two, the indeterminate plane structure. So for this video and the rest of the upcoming video in this playlist, we'll be discussing primarily on determinant plane structure. Now, what are determinant plane structure? A determinant plane structure is a structure that can be completely analyzed using the condition of static equilibrium. Now, when the condition of static equilibrium are not enough to solve a plane structural problem, the structure is referred as being an indeterminate structure. So, for a structure to be classified as an determinate plane structure, such structure should be completely analyzed using the condition of static equilibrium. Contrary, when a structure cannot be analyzed with the condition of static equilibrium, such structure will be regarded as an indeterminate plane structure. Now it's going to require more rigorous procedures to analyze such structures. Condition of static equilibrium. This static equilibrium, let's check out the condition of static equilibrium. One, the algebraic sum of vertical forces is equal to 0. Now the sum of all vertical forces acting on a given structure must be equals to 0. Algebraic sum of horizontal forces is equal to 0. Algebraic sum of horizontal forces is equal to 0. So similar to vertical forces, all the horizontal forces acting on the structure must be equal to 0. And in our main load applied to the main loads apply on structures, these horizontal forces can be classified as wind load. Wind load may act horizontally, or wind load are one of the horizontal forces that act on a structure. So summation of these forces must be equals to zero. Summation of vertical forces must be equals to zero. Summation of horizontal forces must be equal to zero. And summation of moments of all forces about any chosen point should be equals to zero. Summation of moments about a given point must be equals to zero. So these are the conditions of static equilibrium, and this condition must be satisfied before a structure can be classified using static equilibrium, and as such a determinant plane structure. Now let's consider um, another important topic in has you need to know in the basics of structural analysis. It is the sign convention in static equilibrium. The sign conventions in static equilibrium. This should not be new to you, as you must have been taught in your mathematics, both in your secondary school and in your physics. You must have seen that when you have coordinates like this, the y direction going upward are always positive. So if you have the x direction going towards the right are always positive. So if you have zero here, in this coordinate, numbers going toward the left are always positive. Now number going towards the right are always positive. Number going toward the left from this point of zero are going to be negative. So zero is always the center. The same implies to numbers going upward, they are always positive, and number going downward are always negative. So let's take that to structural analysis. You can see from this diagram here, upward forces acting upward, vertical forces acting upward. You can see positive. Here we have horizontal forces to the right direction, positive. Moments, clockwise is always in the right direction, positive. The same implies here, negative this time around. Now let's get the key point. Vertical forces acting in the upward direction are considered as positive forces. Vertical forces acting in the upward direction, you can see the arrow pointing upward, are considered as positive forces, whereas vertical forces acting in the downward vertical direction, you can see the arrow pointing downward, are considered as negative forces. Okay, horizontal forces that tends toward the right direction, you can see the arrow pointing to the right direction, are regarded as positive horizontal forces, while horizontal forces that tends toward the left direction, you can see the arrow pointing toward the left direction, are regarded as negative horizontal forces. Okay, moments. Clockwise movements. As you can see, the arrow is going in the right direction, is rotating toward the right direction, are taken as positive movements. Movements rotating towards the right direction are taken as positive movements. On the contrary, anti-clockwise movements are taken as negative movements. Now, keynote: the core principle of conversion is arbitrary. Consistency is mandatory. What does this imply? It means that the principle of conversion is arbitrary. You can choose to make the movement going toward the left direction to be regarded as positive movement, and you can choose to make movements going toward the right direction to be negative movement. That is why you can see in some structural analysis textbook where you see their movements, some of their movements going to the left direction considered as, or like movements in the clockwise direction considered as negative, and movements to the anti-clockwise direction considered as positive. It is not confusion, or it is not contradicting. The only thing you need to know that it is arbitrary. You can choose to take any direction has been positive or negative. But what you need to consider is that it must be consistent. Consistency is mandatory. Any direction you choose, you must use that direction throughout the whole design. Now, degree of indeterminacy. In our next video, we are going to be discussing on the degree of indeterminacy of a structural member. We are also going to be discussing on free body diagram and analysis of trust. So do well to subscribe to this channel as more video on structural analysis will be uploaded. Thank you and see you in our next video.